You may recall from the problems we've already worked that arithmetic sequences are sequences where we add the same number each time. Now we're going to look at geometric sequences. Geometric sequences, you multiply by the same number each time. Now, in this first section of problems, we're going to classify either as arithmetic, geometric, or neither. So on part A, we're going from 0 to 8. We can accomplish that by adding 8. And then to go from 8 to 16, we'll add 8. If we keep on going, 16 to 24, we'd be adding 8. 24 to 32, we'd be adding 8. So each time we're adding 8, so it's arithmetic. We can say that the common difference is 8. From left to right this time, if we go from 4 to 12, we're adding 8, but then 12 to 36, we're adding 24, so definitely not arithmetic. Think about what number you'd have to multiply. 4 times 3 is 12. 12 times 3, 36. 36 times 3 is 108. So it's geometric. We're multiplying by 3 each time. We call that a common ratio. Now here's why we call it a common ratio. What we can do is take a term and divide it by the previous term. 12 divided by 4 is 3. If we do 36 divided by 12, we get 3. If you do 108 divided by 36, you also get 3. So it's a common ratio. So geometric and our common ratio is 3. Next one. To go from 2 to 6, you could add 4, but then 6 plus 4 is 10, not 9. So it's not arithmetic. You're not adding the same number. Next, you could try multiplication. 2 times 3 is 6. 6 times 3 gives us 18, not 9. So it's not geometric either. Now it appears that you're multiplying by 3 and then adding 3 and multiplying by 3. So even though it's a pattern, it is not fitting either arithmetic, where you add the same number each time, or geometric. So it's neither. On this last one, you could add negative 16. But then on the next one, you would add negative 12. So it's not the same number, so it's not arithmetic. Geometric, I can't think of a number that you could multiply 64 by to get 48. So let's set up our ratios and see if they're common, if they're the same. So we'll do 48 over 64. Divide them both by 16, you'll get 3/4. Or if you change it to a decimal, 0.75. Now do 36 over 48. Divide them both by 12. You get 3/4. And then 27 over 36, divide both of those by 9, you get 3/4. So it's geometric, and our common ratio is 3/4. Now you could show by multiplication that from left to right you multiply by 3/4 each time. 64 times 3/4, you get 48. 48 times 3/4, you get 36, and 36 times 3/4 gives us 27. Next, we're going to find the next 3 terms. So they're already telling you it's geometric. So we just have to figure out, what do we multiply by each time? 2 times 3 is 6. 6 times 3 is 18. Keep that pattern going. So 18 times 3 gives us 54 for the next term. Then do 54 times 3, and you get 162. And then 162 times 3. You get 486. So those are our next three terms. If you do negative 4 divided by 1, you get negative 4. 16 divided by negative 4, you get negative 4. So we're multiplying by negative 4 each time. So do 16 times negative 4 to get the next term of negative 64. Do negative 64 times times negative 4. And you'll get that next term of 256. And then do 256 times negative 4. You get negative 1024. Now notice when your common ratio is negative, you're going to see alternating signs. We started with a positive, then a negative, then a positive, then a negative, and so on. Part C, again, we're told it's geometric, so you can set up your ratio and simplify that, and that'll tell you the common ratio, the number that we're multiplying by each time. So that gives you 1/2. So we need to multiply negative 16 times 1/2. That gives us negative 8. Do negative 8 times 1/2. That gives us negative 4. And then do negative 4 times 1/2. And that gives us negative 2. So next three terms, negative 8, negative 4, negative 2. Here we're going to write an equation for the geometric sequence. A sub 1 is representing the first term. R is the ratio, common ratio. So if we do 6 divided by 2, we'll see that's 3. So our R is 3. Now we'll substitute in. So A sub n equals first term 2, common ratio 3, and it's still going to be in our sequence, in our equation, I should say. All right, A sub 1, first term 1, common ratio. What are you multiplying by each time? Do negative 4 divided by 1, and you get negative 4. So the common ratio is negative 4. Now we'll write our equation for that. So A sub n equals A sub 1, the first term, times the common ratio to the n minus 1 power. Same type of thing on C. A sub 1 is the first term, negative 64. Set up your ratio and simplify it, and you get 1/2 as your common ratio. Substitute into the equation, first term, negative 64, common ratio 1/2, and then your exponent is the n minus 1. Here we're finding the 7th term, so replace n with 7, and then simplify the right side. In your exponent you have 7 minus 1, so simplify that, and that's 6. Bring 2 to the 6th power. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. And then multiply those together. You get 192. So that's the 7th term of the sequence. By the way, you could verify this one pretty easily. Your first term is 3, multiplying by 2 each time. So 3 times 2 gives us 6 for the second term. 6 times 2 is 12 for the third term. Times 2 is 24. Times 2 is 48. Times 2 is 96. We're looking for the 7th term. So this is first, second, third, fourth, fifth, sixth, one more. Times 2, get 192 for the 7th term. Hope you've enjoyed this video.